Alright, let's go over quiz number 5. Math 5A, quiz number 4, chapter 3, sections 1 to 3.2. This was taken on October 20th, 2017. Directions show all your work in the space provided and box your answers for the multiple choice questions. Number 1, find the missing term in the geometric sequence, -5, 10, -20, 40. And if you recognize that you're multiplying each of these numbers by -2, the next number, 40 times a -2, would give you a -80. The answer is A. Remember, if you can't determine the ratio there, as long as you know it's multiplying, you can always take the second term. So I call this G1, G2, G3, G4, G5. And you can take the second term divided by the first term, 10 divided by -5. That means my ratio is -2. You can take the third term divided by the second term. -20 divided by 10 is also -2. Question number 2 says, what type of function is given based on the table? So a couple things you can do is recognize on your x values, they're counting by 1. And I recognize that if I go from this number to this number, it doesn't look like there's a common difference, a first common difference, right? So if you go from here to here, that's 3. And then from here to here, that would be 12. So let's write that 3, and then here would be 12. And then if I took this number, the second difference, that would be 9. So if I go from here, that would be what, 48? Not 48. 64 minus 16, guys. 48. So from here, 48 to 12, that's 36. So I wanted to show you that there's no second common difference. So it's not linear. It's not quadratic. Okay. Now, so not these two. Then the third one is you realize that they're just multiplying by 4. From 1 to 4, just times 4. Times 4. Times 4. Right? So if they have a common ratio, so 1/4 times 4, put it away. It's kind of embarrassing if I said your name on the video, everyone's going to hear you. So I multiply by 4 there. That means you have a common ratio, which means that it's exponential. And of course, if you graph these order pairs, so -2, 1/16. So you can put in your calculator, you get a decimal, you realize it's really small, close to 0. -1, 1/4, 0.25, 0, 1, 1/4, 2/16, something like right there, and then 3/64. You realize that has a curved, it's smooth curved, it goes up and increases really fast, quickly. Question numbers 3 to 8. Identify and circle each as linear, quadratic, exponential, or neither. Question number 3 is exponential. It's exponential because its exponent is a variable. Question number 4, if I look at this equation, it's quadratic because its highest power is 2. The highest power is 2. So if you're doing your corrections and you miss that question, you shouldn't just be pointing like an arrow, you should write an explanation. It's quadratic because it has the power of 2. Use words. Question number 5, I recognize that there are no powers, it's to the first power. Therefore it's linear, and of course you can always subtract 5x from both sides. And you get y equals -5x plus 8, and that's also in the form of mx plus b, slope-intercept form. Question number 6, I have a parabola. Parabolas are quadratic. Question number 7, this v here is an absolute value, so this is an absolute value. And absolute values are functions, right? Passes the vertical line test. Quadratic also passes the vertical line test, but it's not a smooth curve, therefore the answer is neither. Question number 8, you have a smooth curve and it increases quickly, so this one is exponential. So these were only 1 point apiece. So that's 6. And then this one was 2, and 2. First name, last name, and period. I think I'm eventually going to take that away. So 7 plus 6 is 13 points for that side. Back side. Draw design 7. So it gives me the first 3 designs here. My first 3 designs here are, I have these white squares there, and notice that it's a square. Alright, so we're going over the back side. If you'll recognize that in question number 9A it says draw design 7, they have designs 1, 2, and 3, and you'll notice that there's this box here. And I notice that the white boxes are on the top left and the top right. Well, if I notice something, it says design 1 has a 1 by 1 box. And this one is a 2 by 2 box. And this one is a 3 by 3 box. So that means design 7 is going to have to be a 7 by 7 box. And a 7 by 7 box then, and it also has the 2 white boxes there. Okay, so the 7 by 7 box, that'll give you 49 plus the 2 white ones. So we can call it 49 shaded ones plus 2 unshaded equals our whole. Our whole is 51. So I gave you 2 points for drawing this. If you drew the white boxes like one over here and one over here, or some awkward position like onto the right side, I gave you guys 1 point. Question 9C. Complete the table. So design number 1, 2, and 3, and then I added it, so put 4, and you can have n there. And here you have a total of 3 square boxes. Here you have the 4 plus the 2, so that gives you 6. This one is 9 plus 2 is 11. And if you recognize our pattern here, first common difference would be linear. So to go down, this would be plus 3, plus 5, and then plus 7. So it's not linear because this is not a first common difference. Then I'm looking for a second common difference. Well, that means if I go from this number to this number, that'll be 2 and then 2. So it is a second common difference. So the answer is 9D. Let me go back to the table. If you wrote the numbers 3, 6, 11, and 18, you got 2 points for all 4 that are correct. You got 1 point if you got 2 of these correct. 9D, it is quadratic. It's quadratic because of a second common difference. Second common difference. Remember, you should be doing your corrections on the side. Question 9E. Write in an algebraic expression to represent the total number of squares in design n. So the easy way to do this is looking at your table. You have a hint. It's quadratic. And then I have these numbers, right? 1, 2, 3, 4, and then you'll add the letter n here. So if I take this number and square it, let's take an easier example. Let's take up this one up here. If I take 3 and I square it just means that it makes a square. So a 3 by 3, you square it and you get 9. Well, I don't have 11 here. I have to add the 2. So there you can see that this 2 here represents those white tiles. So if I take any n value and I square it and I add 2, I have my expression n squared plus 2 is your answer. The algebraic expression is n squared plus 2. Notice over here I gave partial credit. If you just wrote n squared, I gave you 1 point, or if you wrote n squared minus 2, I also gave you a point for that one. Use your algebraic expression to determine the total number of squares in design 52. So here they're telling me that n is equal to 52, and I have n squared plus 2. Well, if design 52 is 52, I can just put that for every n value. So I get 52 squared plus 2. Add those together, you'll get 2,706 is your answer. And one last time, let me show you guys how to do the Ken so that you can get 100% on these. To easily increase your grade, fill in the blank square so that each row, this is a row, and each column contain all the digits 1 through 4. Numbers in a cage may repeat, so a cage has the darkened lines, as long as they are not in the same row or column. So to do a problem like this, pencils with me, I'll do this one on the side over here. I'll redo it like the first time. First thing I'm going to do is I'm going to look for all the freebies. All the freebies have a darkened cage around it, and there's no math operation there, so my 1 is my freebie. I need to think of numbers in here that'll have the numbers 4, 3, and 2, right? So let's go here. I need 2 numbers that add up to 3. Well, that's only a 2 and a 1, and notice I can't put a 1 here because it'll repeat. So I have to put the 2 here and then the 1. 2 plus 1 equals 3. I need the numbers 3 and 4 in here to complete this row, and here they have to add up to 11. So if they add up to 11, if I put 3 and 4 here, this is 7, and then what number does this have to be? A 4. So you'll notice I don't want to put a 4 here because it'll be repeating. So I'm using my pencil. Thanks to Irene. I'm going to switch the places 4 and 3. So there I have the numbers 1 to 4 not repeating, and I have 7. Now I have to have a 4 here. In this cage right here, I need 3 numbers that multiply to be 4. I could choose 4, 1, and 1. 1 times 4 is 4, 4 times 1 is 4, but I already have a 4 here and a 4 here. So I'm probably going to choose the numbers 2 and 2. Well, how do I get 2 and 2 so they're not in the same row or column? I have to put them in the corners of each other. Do you see that? 2 times 1 times 2 equals 4. 2 numbers that add up to be 4. I can't choose 2 and 2. I can't do 4 and 0 because 0 is not a number 1 to 4. So it's probably going to have to be 1 and 3. Class, what number am I going to put there? I'm going to put a 3 and I'll put a 1. So you'll notice that there's no repeating numbers here, no repeating numbers, and these add up to be 4. I'm going to go back and look for the ones I have 3s for. So I have 1, 2, and 4. What number am I missing there? 10 take away 3 is 7, so these have to add up to be 7. So this one has to be a 4, and this one has to be a 3, so that there's no repeating numbers there, and that adds up to be 10. What number am I missing? 2. And this one? 4. So 2 times 4 is 8. No repeating numbers. No repeating numbers. So if you add up all of your points on this page, you have 2 points for drawing it, 1 point, so that's 3, 5, 1 point each, 5, 6, 7, 9, 11, plus this one is either 4 or 1 if you tried it, so that's 15 points, and then 13 plus 15 gives you 20 points.